Hello YouTube, De-bodgery here. Welcome to EV Components Review. This video, I'm going to explain what all these wires and stuff are on this VESC controller made by Torp. Yes, this is a TC500 controller made by Torp using the full implementation of VESC. So this is not my opinion per se, although I'm more than willing to stand on my own opinion and say this is VESC. I have been in conversation with several VESC engineers. I have stated this before that I talk to these people, and well, I do. Before I ever even got the thing, and back when I first found out about Torp, whatever that was, 6 months ago or 5 months ago, I looked at the thing and thought, I'm pretty sure that's VESC. The functionality is all there. Looking at the kind of people that supposedly developed this controller, they lack the skill set to do the very complex part, namely the motor control, which VESC has in spades, done by a really smart guy, Benjamin Vetter. I mean, damn, that guy's got an IQ just out of this planet. He is a really, really smart man. It takes people like that to create properly good field-oriented control like VESC has in it. And very, very, very few people can do that. In fact, like the folks at ASI, to do what Benjamin Vetter did since 2014, it took them way longer. He's a really, 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 really smart guy. The guy is an absolute genius. Truly he is. So anyway, this is the kinds of people that I have access to. Very brilliant people that do actual VESC controller development. Alright, so they were telling me that this is VESC before we ever cracked the cover. And then once I cracked the cover, then they were saying, that's VESC. There was not a whole lot of doubt left. But you're also talking of people that are very technical, and they are very specific about things when they say them, and so they're still giving this the opportunity to not be VESC, and so they asked me to do a bunch of stuff to this thing, and that's what you're looking at here. Alright, so first things first, and this is all to prove, just absolutely dead sure, emphatically, without any possible shadow of a doubt that this is VESC. So these two wires right here, that's plus 5 volts and ground. I have them wired up across the 3.3 volt linear regulator, and when I apply 5 volts here, that immediately powers up the STM32 F405 and the Bluetooth module, which would be mounted right here, which is sitting right here. Also, right next to it is the 5 volt DC to DC converter, and its output goes directly to that linear regulator. So by applying 5 volts to the input on that thing, I'm also applying 5 volts to everything else that needs it. Like, say, this op amp, or the CAN bus chip, or all these little support electronics. All this stuff gets powered up right then and there. And this is a very trivial thing. I didn't even need to look at a VESC schematic to know that that would work. But nevertheless, you can look at all the VESC schematics, and they do this. Exactly, because this is VESC development. This is such a seriously close copy of the Trampo 100-250 as to say, it's almost exactly identical with a few little tiny changes. Nothing that would say, oh my god, that's not a Trampo 100-250. Anyway, all that logic stuff gets powered up just with those, and I need that because I'm going to hack that CPU. So I've got 5 volts and I got 3.3 volts with those two wires. Alright, so once that was powered up, then I could do some actual hacking. And the first thing was the Bluetooth module was mounted here, and so I connected to it with a phone that had the latest VESC tool on it, and tried to connect to it with VESC tool, and VESC tool wouldn't do it. And that's a fairly trivial thing to make that not work. Basically, the firmware in this Bluetooth module, you just change the identifiers in it so that it doesn't identify as a VESC device, and VESC tool doesn't connect. And that's not very hard to do. I can do that. Actually, that's not rocket science. Anybody who understands Bluetooth modems can get in there and make those kind of settings. Anyway, so this has got firmware on it, it's got configs on it, all that kind of stuff. By the way, this is a very inexpensive Bluetooth module. Flip Sky uses this same module, And yeah, it's a very inexpensive one. You can buy them like on AliExpress for $2 or $3. Whereas like this one here, which is what this Trampa 75300 has in it, and a lot of other better VESC stuff uses, this Regato Bluetooth module. This is a much better Bluetooth module, and they don't cost $2 or $3. They cost a lot more. Either one, though, you know, it's just firmware on the thing and how you use it that makes things happen. So I'll get back to Bluetooth after a while. Anyway, connecting to Bluetooth with Windows or Android and the VESC Tool apps didn't work, so that's the easiest thing to do. And keep in mind that there are 7 ways to get in to VESC, so, or into the CPU rather. So yeah, that eliminated a couple of them right off the bat, and that didn't work, so pull that aside. That was really, really obvious. You know, somebody who wants to connect to this thing with VESC Tool, you don't cover Bluetooth. All I can say is you weren't even trying. You weren't even trying to hide the fact that you're VESC. Yeah, because, you know, everybody's going to have Bluetooth capability. Putting VESC Tool on your laptop or your phone, come on, that's really easy to do. That's an easy one to test. So yeah, they did change that identifier information so that it doesn't work. All right, so the next thing was USB. So again, you can look on the VESC schematics and find out the pins for USB, and they are the exact same ones on this chip as they are in everything else VESC. The exact same ones, and it's live. And so that is a micro USB connector, and I've soldered ground and data plus and data minus over to here and to the ground plane on here, and plugged in a USB cable to my laptop. And dunk, da, da, dunk, yep, Windows detected it. Device Manager shows that this is a Torp TC500, and then VESC Tool tries to connect and goes, I don't see a VESC device. Again, this is a fairly trivial change, again, for USB identification, to change the identifier field to something that VESC Tool won't recognize. So yeah, 2 out of 2 didn't work. But that's not really damning in any way. That doesn't say, oh, this isn't VESC. It just means that they changed some very trivial things to make it not look like VESC. All right, so here is the third hack right there. And CAN bus chip is right there, so CAN high and low. And they actually do go to this I/O connector because it needs it. And so these 2 wires right here, I soldered them right to the pins on this connector for CAN high and CAN low. And then this right here is a clever little bit of kit rather from Trampa. This is a VESC Express, and let me talk about that for a second. So that's a GPS module, and there is also an accelerometer on here. I forget where that is. I think it's in the GPS module. You also have an ESP32 on here, which has Wi-Fi, Bluetooth, a bunch of I/O, plus a fairly powerful processor. So this is a really cool little device. You can buy these things for like $10 on like an Amazon or eBay or whatever. But anyway, yeah, it's a great little platform for doing all kinds of clever development, and they've got one on here on this VESC Express. You got USB-C. You've got a UART here, which is how this is communicating. I'm pretty sure that's UART. And you've got CAN bus on here, and on the back side, you have a SD card slot and a linear regulator, a couple other support components, like that right there. This little chip. That's your CAN transceiver. Anyway, VESC Express. Plug this in via USB or connect to it via Wi-Fi or Bluetooth, and it will immediately identify itself as a VESC Express in VESC Tool. So very handy little device, and it gives you a lot of functionality that you don't currently have in anything VESC right now in this little device. You know, give it a little while, and with that ESP32, the libraries are all there to add cell phone service. You know, so now you have a cell module with a SIM card in it, and you have a GPS module and the right software. You have a GPS tracker built into VESC, and that's coming. It's just not developed yet. So here's the hardware for it. Just need to plug in one other device, you know, the cell phone module, and ta-da, Bob's your uncle, and this becomes a GPS tracker, and you don't have to have, you know, that $60 every 3 months or whatever service like I have for GPS tracking for my EVs. All right, so yeah, this does a lot of stuff, and it has CAN bus on it. So yeah, plug this into there, connect this up to my laptop via USB or Wi-Fi or Bluetooth or whatever, and this immediately identifies itself in VESC tool, and then do a CAN scan to detect other things over CAN bus, and well, that didn't work. And again, that's a fairly trivial change, and the VESC libraries and all of the code base are public and available, so anybody who can do some basic programming can go read those things and go find the identifiers for CAN bus and change them so that this doesn't identify itself over CAN bus as a VESC controller. So a trivial change to make this not say, I'm VESC. So anyway, CAN bus didn't work. All right, so the next hack, and this is why the Bluetooth module is not soldered down. All right, so there is a repo that I mentioned in my last video called Blackmagic, and I cannot prove at this point in time that Blackmagic is used here, but all of the hardware connections are, so that's fairly compelling by itself. Anyway, SWD clock and I/O here, TX and RX are here, and the other couple signals that you need are over here as well to make that all work. I have this unsoldered, and I'm not going to use SWD clock and I/O. I'm going to use TX and RX over here only. And this is going to be another backdoor attempt in. So with this Bluetooth module on there, it identifies itself as something not VESC, in which case VESC tool says, oh, sorry, it's not VESC, and doesn't connect. But this right here is a Trampa 75300, and this is fully VESC. Yep, see, it even says VESC on it. And it's got this Regado Bluetooth module on here, which has got the right firmware in it to identify itself as a VESC device. And I'm going to take TX and RX off of here and wire them down over there, connect to that Bluetooth module with VESC tool, and I'll bet you anything I get right on in. And that works. So I doubt they changed the identifiers inside the CPU to happen over Bluetooth. They just changed the identifiers at the Bluetooth module. And that's probably going to get right around that stuff, and what, Bob's your uncle, and I'll be talking to the thing with VESC tool. In which case, there is literally, at that point in time, 0 chances in the entire universe that this is not VESC. Yeah. So anyway, yeah, this has got to get powered up, and on the back side here is the 5-volt DC to DC, and that little cap right there is the output side of that. So just like I did here, I will apply 5 volts to this, or I could also just do it over USB, which is right there. Apply 5 volts there, and then this thing goes live with 5 volts and powers up. And then I will have this little 3.3 volt DC to DC right there power up, and that's going to power this guy. And then, being that this is a standard VESC implementation, TX and RX for the Bluetooth module are right here. I forget which pins it is. Wire those to those, and Bob's your uncle. I am communicating with a real live VESC properly programmed Bluetooth module to this thing, and probably VESC tool is going to work. But there is a chance that that will not. You know, I've already had a couple other attempts that didn't work because they changed the identifier, so maybe they have changed the firmware and dealt with that issue. But, you know, this is harder to do, right? Have to pull up the Bluetooth module, use another one, wire it all together, all that kind of stuff. They may not have thought of that one, because that's a fairly clever hack. And I'm still not done. Okay, so let's pretend like this one doesn't work, and it's probably gonna. There is still 2 more. All right, so I'm pretty sure that, see, it says it right on here. Yeah, that's it. So this is the SWD I/O connector. With the right interface plugged in here, you can reflash your STM32F405 if it bricks, or you can use it to pull firmware off, all that kind of stuff, of which you can't do that on here because, well, there's no SWD I/O. The pins are literally soldered down and floating. And it's the same ones as are on here. So all the pins on these chips, you can assign them to whatever you want. They don't have to be assigned the way they are. But the fact that Bluetooth, or I'm sorry, USB is, and SWD I/O pins are going nowhere, you know, just like according to the spec, there's, again, another smoking gun that's VESC. So I just got to solder a couple wires to the legs on there, like I did for USB, and then I've got the SWD I/O connector going right to the CPU, and probably with the right interface, that's going to glove life, and I'll have access to CPU. So, yeah, most likely all those libraries are there, everything's there, all the pinouts or everything are all the same. And then there's still one more hack to try after that. So, in the comms port, or connector, you have UART, TX, and RX. With an FTDI adapter, you have a terminal session, terminal app on your computer, and you're literally passing commands to and from the CPU. And getting the displayed results of whatever that was on your screen. So I do that, TX and RX, again, solder onto the legs on here, and they're floating, they're not going anywhere, so it's the same legs too. Yeah, just solder those wires on there, use an FTDI adapter and a terminal session, and talk to the CPU directly, and Bob's your uncle. Or use an ST-Link, of which I have one of those too, because, you know, I mess with electronics just a skosh. I'm not some idiot that doesn't know what the hell he's talking about. Use the TX and RX and an ST-Link, and then plug that into a USB port on my laptop, and then connect up VESC tool, and again, Bob's your uncle, and you're in. So there is a fairly good chance that both of those ones will work as well. If Bluetooth doesn't work. So I'm slowly eliminating the 7 different ways that you can get into a VESC implementation on an STM32F405. And pretty darn sure one of those last 3 that are still left to be done are going to work. So anyway, that's what I'm doing. I am hacking this thing to remove the slightest shadow of a doubt that's left that this isn't VESC development. And those ones are going to probably let me in. Most likely the folks at Torp were not clever enough to cover all of those bases. And then we'll know, absolutely flat out, without a shadow of a doubt, that this is VESC. And those shadows are very, very, very dim shadows. So folks, I do actually talk to VESC engineers on a regular basis. Since I got this one, I've been talking to them pretty much daily, you know, and it's not just 1 or 2. There's a special subthread specifically for this, where there's a whole bunch of them talking to me, like, say, I don't know, 30 of them that are part of that. And yeah, they're asking me questions, they're telling me stuff to do, things like that. So yeah, the only way I can pull off this kind of stuff, depotting the thing, adding wires to the right legs, all this kind of thing, is because I'm not a dumb shrub, like some of you have claimed. You know, you actually have to have some electronics background to be able to pull this kind of stuff up, you know, off. So soldering, just that one thing alone, you have legs here that are 0.5 millimeter across on the CPU. I would like to challenge anyone, or, okay, 99 of the people that say, I don't know what the hell I'm talking about, I'm just making opinion pieces, I challenge every single one of you to solder onto 2 0.5 millimeter legs that are side by side so that you can bring out USB. Go ahead, let's see you do that one. I did. They're right there. I already know it works because I've already connected to my laptop through that right there. Love to see you do that one. Oh, here's another one, guys. So I want you to look at the data sheet for the CAN bus chip, which is right there, and I want you to find CAN high and CAN low, and then run 2 wires to it. Go ahead. If I'm such a shrub, I shouldn't be able to pull that off either. And yet, you know what I did? I looked at the data sheet and figured it out. Because, well, you know, I kind of mess with electronics. TX and RX. So this little Bluetooth module, you can find the data sheet for that too. And you can find where the SWDIO, SWD clock, TX and RX are on here. You can find all that stuff. So from there, I can then go with these solder pads, and I can go around every single one of the pins on the CPU and find out where they go. Again, I challenge any of you out there that, you know, think I don't know what the hell I'm talking about to go do that yourself. I'll bet none of you can, or only a few of you might be able to. Anyway, you actually have to understand what the hell you're talking about to be able to pull that stuff off. And then, to do this too, here's a completely separate VESC controller that I have used hot air to remove the CPU. You know, it's reflow soldering, or deflowing, or whatever you want to call it. It's reflow soldering, you know, hot air to pull the CPU off. And then I'm going to power this thing so that I can then take TX and RX off of this one and put it down to here. Again, I challenge all you people who think I'm just some dumb shrub to pull that one off too. Yeah, I'm not an idiot. I actually have some clue what the hell I'm talking about. Yeah, Anyway, more hacking coming. Hope to help some folks out, and now you understand what all this wiring is on here.